Electrical metallic tubing, abbreviated EMT, stands out as the superior choice for wiring new offices within a manufacturing facility, especially one involved in metal fabrication processes like cutting and welding. Firstly, let's delve into the protective capabilities of EMT. The metal conduit acts as a robust shield for electrical wires, safeguarding them against sparks and debris commonly produced by welding and cutting operations in the adjacent shop. This protection is critical to prevent damage to the wiring, insulation, and potential electrical hazards. Secondly, the durability of EMT is a significant advantage. Manufacturing facilities are often characterized by harsh conditions including vibrations, dust, and temperature fluctuations. EMT, being a robust and durable material, can effectively withstand these challenges, ensuring the long-term reliability of the electrical system. Thirdly, code compliance plays a crucial role in electrical installations. The National Electrical Code, referred to as NEC, often mandates the use of EMT in industrial settings where there is a risk of mechanical damage or exposure to water. Compliance with the NEC is essential for ensuring the safety and proper functioning of the electrical system and for meeting regulatory requirements. Fourthly, fire resistance is another important aspect. EMT is a fire-resistant material that can help contain and prevent the spread of fire in the event of an incident. This fire-resistant property adds an extra layer of safety to the electrical system, protecting both personnel and property. Now, let's examine why Romex, also known as non-metallic sheathed cable, is not recommended for this application. Romex is typically used in residential and light commercial applications due to its cost-effectiveness and ease of installation. However, it is not as robust as EMT and is more susceptible to damage from sparks and debris. Additionally, Romex is not fire-resistant, which makes it less suitable for industrial environments where there is a higher risk of fire hazards. Furthermore, consider why metal-clad cable, abbreviated as MC cable, isn't the optimal choice either. While MC cable is a flexible metal sheathed cable suitable for industrial settings, it falls short of EMT in terms of durability. The harsh conditions of a manufacturing facility can more readily damage MC cable compared to the sturdier EMT. Now let's delve deeper into the technical aspects and code requirements related to the use of EMT in industrial settings. When installing EMT, it's crucial to adhere to the NEC guidelines for proper support and securing of the conduit. The NEC specifies the maximum spacing between supports for EMT, which varies depending on the size of the conduit. For example, for 1-inch EMT, the maximum spacing between supports is typically 10 feet. It is important to consult the specific NEC table, such as Table 344.30b2, to determine the correct support spacing for different sizes of EMT. Furthermore, proper grounding and bonding are essential for ensuring the safety of the electrical system. The NEC requires that all metal enclosures and equipment be properly grounded to provide a low impedance path for fault currents. This helps to prevent electrical shock hazards and minimize the risk of fire. When using EMT, it's important to use appropriate fittings and connectors that are listed for use with EMT. These fittings should provide a secure and reliable connection between the conduit and the electrical boxes or equipment. Additionally, when running EMT through fire-rated walls or floors, it's important to use fire-stopping materials to maintain the integrity of the fire barrier. These materials help to prevent the spread of fire and smoke through the openings in the wall or floor. Furthermore, consider the importance of selecting the appropriate size of EMT for the intended application. The NEC specifies the maximum number of conductors that can be installed in a given size of conduit. It's important to calculate the total cross-sectional area of the conductors and compare it to the allowable fill percentage specified in the NEC. For example, for 3 or more current-carrying conductors, the maximum allowable fill percentage is typically 40%. Also, consider the environmental conditions when selecting EMT. In corrosive environments, such as those with high humidity or exposure to chemicals, it's important to use EMT that is specifically designed for corrosive environments. This type of EMT typically has a special coating or finish that provides added protection against corrosion. In addition to the NEC requirements, It's also important to consider any local codes or regulations that may apply to electrical installations in the specific jurisdiction. These local codes may have additional requirements or restrictions that must be followed. Furthermore, it is good practice to conduct a thorough inspection of the ENT installation to ensure that it meets all applicable codes and standards. This inspection should be performed by a qualified electrical inspector. This inspection should include checking the support spacing, grounding and bonding connections, and the proper use of fittings and connectors. In addition to protection from sparks and debris, durability, code compliance, and fire resistance, ENT offers several other advantages in industrial settings. ENT is relatively easy to install and can be bent to accommodate various installation requirements. It also provides a neat and professional appearance, which can be important in office environments. Furthermore, ENT is a cost-effective wiring solution compared to other types of conduit, such as rigid metal conduit. This can be a significant factor when considering the overall budget for the electrical installation. Now let's discuss the specific tools and equipment needed for installing ENT. The basic tools include a conduit bender, a conduit cutter, a reamer, a screwdriver, a level, and a measuring tape. A conduit bender is used to bend the ENT to the desired angle and shape. A conduit cutter is used to cut the ENT to the required length. A reamer is used to remove any sharp edges or burrs from the cut ends of the ENT. A screwdriver is used to tighten the fittings and connectors. A level is used to ensure that the ENT is installed straight and level. A measuring tape is used to measure the distances and lengths of the ENT runs. In addition to these basic tools, there are also several specialized tools that can make the installation process easier and more efficient. These include a fish tape, a knockout punch, and a hydraulic conduit bender. A fish tape is used to pull wires through the conduit. A knockout punch is used to create holes in electrical boxes for the ENT connectors. A hydraulic conduit bender is used to bend large sizes of ENT. When working with ENT, it's important to follow all safety precautions. Always wear safety glasses to protect your eyes from flying debris. Use gloves to protect your hands from sharp edges. Work in a well-ventilated area to avoid breathing in dust or fumes. Disconnect the power before working on any electrical circuits. Furthermore, it is good practice to use a circuit tester to verify that the circuit is de-energized before starting work. Now let's delve into the specifics of grounding and bonding when using ENT. The NEC requires that all metal enclosures and equipment be properly grounded to provide a low impedance path for fault currents. This grounding is achieved by connecting the metal enclosures and equipment to the grounding electrode system, which typically consists of a ground rod or a metal water pipe. When using ENT, the conduit itself can serve as the equipment grounding conductor, provided that it is properly installed and connected. This means that the ENT must be securely connected to the electrical boxes and equipment using listed fittings and connectors. Additionally, the NEC requires that a bonding jumper be installed around any non-conductive sections of the conduit run, such as flexible couplings or expansion joints. This bonding jumper ensures that the grounding path remains continuous throughout the conduit run. Furthermore, it's important to consider the size of the equipment grounding conductor. The NEC specifies the minimum size of the equipment grounding conductor based on the size of the overcurrent protection device protecting the circuit. For example, for a 20 amp circuit, the minimum size of the equipment grounding conductor is typically 12 American wire gauge copper. It is important to consult the specific NEC table, such as Table 250.122, to determine the correct size of the equipment grounding conductor for different circuit sizes. In addition to the equipment grounding conductor, it's also important to consider the grounding electrode conductor. The grounding electrode conductor connects the grounding electrode system to the service equipment. The NEC specifies the minimum size of the grounding electrode conductor based on the size of the service entrance conductors. For example, for a 200 amp service, the minimum size of the grounding electrode conductor is typically 6 American wire gauge copper. It is important to consult the specific NEC table, such as Table 250.66, to determine the correct size of the grounding electrode conductor for different service sizes. Now, let's discuss the specifics of fire stopping when using EMT in fire-rated walls or floors. The NEC requires that all openings in fire-rated walls or floors be properly sealed to prevent the spread of fire and smoke. This sealing is achieved by using fire-stopping materials that are specifically designed for this purpose. When running EMT through fire-rated walls or floors, it's important to use fire-stopping materials to seal the openings around the conduit. These materials typically consist of a putty-like substance or a foam that expands when exposed to heat. The fire-stopping material should be installed in accordance with the manufacturer's instructions and should completely fill the opening around the conduit. Additionally, it's important to select fire-stopping materials that are listed for use with EMT and that have a fire resistance rating that is equal to or greater than the fire resistance rating of the wall or floor. The fire resistance rating is typically expressed in IRs, such as 1 IR, 2 IRs, or 3 IRs. Furthermore, it's important to inspect the fire-stopping installation to ensure that it is properly installed and that there are no gaps or voids. Any gaps or voids should be filled with additional fire-stopping material. It is also good practice to label the fire-stopping installation with the date of installation and the type of fire-stopping material used. In addition to the technical aspects of EMT installation, it's also important to consider the aesthetic aspects. In office environments, it's often desirable to conceal the EMT conduit to create a more visually appealing space. This concealment can be achieved by running the EMT in the walls or ceilings, or by using surface-mounted raceways. When running EMT in the walls or ceilings, it's important to ensure that the conduit is properly supported and secured. The NEC specifies the maximum spacing between supports for EMT, which varies depending on the size of the conduit. Additionally, it's important to avoid running the EMT in areas where it could be damaged by nails or screws. When using surface-mounted raceways, it's important to select raceways that are compatible with EMT and that provide adequate protection for the conduit. The raceway should be securely mounted to the wall or ceiling and should be painted to match the surrounding decor. Furthermore, it's important to consider the color of the EMT conduit. EMT is typically available in a galvanized finish, which has a silver-gray appearance. However, it can also be painted to match the surrounding decor. When painting EMT, it's important to use a paint that is compatible with galvanized metal and that is designed for outdoor use. The paint should be applied in thin, even coats to avoid runs or drips. In conclusion, electrical metallic tubing, abbreviated EMT, is the best choice for wiring new offices in a manufacturing facility due to its protection from sparks and debris, durability, code compliance, fire resistance, ease of installation, and cost effectiveness. When installing EMT, it's important to follow all applicable codes and standards, use appropriate tools and equipment, and take all necessary safety precautions. By following these guidelines, it is possible to create a safe, reliable, and aesthetically pleasing electrical system that will provide years of trouble-free service. Remember to consult the latest edition of the National Electrical Code and local codes for the most up-to-date requirements and regulations.